Hey guys, so I've had a lot of questions about the matching of the secant and cosecant graphs. So I wanted to walk through that a little bit with you. But first I wanted to walk through some of the main characteristics of these two graphs so that you knew which parts to look for to make sure that this is as easy as it can be for you. So first I'm going to draw a secant graph and a cosecant graph, and we're going to look at the identifying features of these graphs that'll make it easier for you to graph them and match the graphs. All right, so I'm going to do this like that. Okay, so a normal secant and cosecant graph, first of all, they both have periods of 2 pi. We've talked about that before. So we're going to do pi right here, 2 pi right here. We'll go pi over 2 in the middle, 3 pi over 2 there. All right, now a secant graph, remember, is 1 over the cosine graph, so it has those vertical asymptotes anywhere cosine is at 0. All right, so cosine is 0 at pi over 2 and 3 pi over 2. So the normal secant graph is going to have those vertical asymptotes at pi over 2 and 3 pi over 2. All right, and then the normal secant graph is going to start at the maximum. That's going to be +1. This is going to be -1. The normal secant graph is going to start at the maximum of cosine and make a half of a cup at the beginning of the period. It's going to be at the minimum of cosine and make an upside down cup at pi. And then it's going to be back at the maximum of cosine at 2 pi and make that half cup inward. So one period of secant is made up of 2 half cups and 1 whole cup. And I'm going to move those vertical asymptotes out of the way so you can see on this graph what you're looking at. Oh, good. It looks like I can only move one of those little dashes at a time. That's stupendous. We'll just, move all of the things. All of the things. Hope you guys are having a good weekend so far. And I am having a great time cleaning my house, hoping it doesn't rain in a little bit. Gonna do some more math probably. Okay, here we go. So this is what one period of secant looks like. Now, notice a couple of things that you can look for when you are matching these graphs. First of all, secant has a minimum, a bottom of my cup, right there at x equals h, okay? So when you're looking for the secant graph, it should have a bottom of the cup at x equals h, okay? Wherever h is, you should have a bottom of the cup, all right? Another thing that you can look for with the secant graphs is where the vertical asymptotes are. The vertical asymptotes are wherever x minus h equals 0. All right? So wherever x minus h equals 0, that's where those vertical asymptotes are. So that's 2 things that you can look for when you're looking for secant. All right? Now, let's do our big squiggly line because we're going to switch gears here and let's talk about cosecant. So the cosecant graph is 1 over the sine theta. So that means that there's going to be vertical asymptotes for this one wherever sine is 0. And that happens at 0, pi, and 2 pi. Okay, so again, if we call this 0, we're going to call this pi, we're going to call this 2 pi, and then this will be our pi over 2, and this will be our 3 pi over 2. We're going to have those vertical asymptotes, make it easy on myself this time. We're going to have those vertical asymptotes at 0, at pi, and at 2 pi. That's where cosecant is undefined. Now, when you're looking at the cosecant graph, you're going to see that the bottom of the cup is going to be at the maximum of the sine function. So that's at 1. We know, oh, my goodness. Go away. Go. There we go. And the minimum is at -1. So cosecant is going to have the bottom of that cup at pi over 2, and it's going to go up towards those vertical asymptotes. And then 3 pi over 2 is going to be the top of the cup. The maximum of the cup is going to be the minimum of the sine function. So that's going to be right there. And notice that for the cosecant function, the whole period of the function, one cycle of the function, looks like just 2 cups. So let me move those vertical asymptotes out of the way. Let's get rid of those now because you won't see those on your graph. So if you look here, cosecant should have 2 full cups 2 full cups in 1 period, okay? So in this case, we should have a vertical asymptote at x equals h. So one thing that you look for cosecant is a vertical asymptote at x equals h. And there should be vertical asymptotes everywhere that x minus h is, that x equals h. All right, so that's one thing that you can look for when you're looking for the cosecant graphs. Also, notice with positive graphs, that means that the A is positive, okay, both of the cups are up cups first. Both of the cups are up first on both secant and cosecant, okay? So I'm going to leave this screen here. You can always pause this video, come back to this screen if you need to, but let's take a look at one of these functions and see if we can match where it's supposed to go. Okay, so this is the very first function that you have. This is graph 11, and we need to match that to one of our graphs. So let's take a look here and see what we can figure out from this function. First of all, we can see that it's secant, and remember, we said for secant, there should be a, go back here, for secant, there should be a minimum for an up cup at x equals h, okay? So we should start our cup at x equals h. Cup at x equals h. So that means that there should be a point at wherever h is where this cup starts to go up like that. And turns out that should be at positive pi over 2, okay? So we should have an up cup, because this is a positive function, an up cup at x equals pi over 2. Knowing that, let's go to our graphs, okay? So we're looking for an up cup at x equals pi over 2, all right? And we know that pi over 2 is halfway between 0 and pi. So let's see which one of these we can get rid of. All right, so if you look at graph K, this is pi, so that means that pi over 2 would be about right here. Do you see an up cup at pi over 2? No, you don't. You see a vertical asymptote at pi over 2, but you do not see an up cup at pi over 2. So that cannot be the graph. Look at L. If this is pi, then pi over 2 should be in the middle. And notice right here, we have an up cup that starts at pi over 2. So we're going to leave that one alone. All right, let's take a look at P. If you look at graph P, if that's pi, then this is pi over 2. And notice again, we have an up cup right there. So we're going to keep that one as well. Look at graph Q. At graph Q, this is pi, so this is pi over 2. Do you see an up cup right there at pi over 2? No, you don't. You see a vertical asymptote, so that one's not okay. Look at graph R. Again, if this is pi over 2, and notice that you have a vertical asymptote there as well. That is not an up cup, so that cannot be this graph. Okay? Looking at graph T, you see how this is pi over 2. I see a down cup, which means that would be a negative secant. And since this one's not negative, it's positive, that can't be the graph either. All right, so we are now down to just 2 of these graphs. We're looking at graph P and we're looking at graph L. All right, so now let's see if we can figure out the difference between graph P and graph L. If you notice in graph L, this would be the start of our period, and then we have our down cup, and then out here, if we kept that going, if that was 2 pi, at 2.5 pi, which would be 5 pi over 2, we would have another start of an up cup, like that, okay? So one period in this graph goes from pi over 2 to 5 pi over 2. So it goes from pi over 2 to 5 pi over 2. Now, if you look at graph P, notice its period. It starts here at pi over 2, and then it has its down cup, and then the other half of its up cup stops right here, and that is at 3 pi over 2. So this one starts at pi over 2 and ends at 3 pi over 2. So the period of this graph is 1 pi, and the period of graph L is 2 pi. Now, going back to our function, so we need to know, is the period pi or is the period 2 pi? Well, remember, the period is 2 pi over b. In this case, there's nothing in front of our x, so that's just 1, which means it's 2 pi over 1. So notice the period of this graph has to be 2 pi. And we can see from our graphs here, the graph that has a period of 2 pi is graph L. So graph L is the one that matches this function. So this is going to be graph L. Now, let's go to our descriptions and see if we can figure that out. Okay, so first of all, we know that the amplitude is none, and all of these say the amplitude is none. Okay, now let's take a look at the next thing that it lists here is the vertical shift. So we've looked at the amplitude is none, so we can't eliminate anything. The next thing we need to look at is the vertical shift. Let's go look at the vertical shift. Remember, the vertical shift comes from K. Okay, so the vertical shift on our graph, there is no K. K equals 0. So there is no vertical shift. All right, let's see if we can go eliminate anything. No vertical shift. All right, this one says none. This one says none. This one says none. This one says none. This one says up to, so we can get rid of that one. And this one also says up to, so we can get rid of that one. All right, so we're down to 4 now. The next thing says the phase shift. The phase shift comes from H. Remember, if H is negative, we're going right. If H is positive, we're going left. So if you look at our graph, H is negative because there's a minus sign in there, which means we're going pi over 2 units to the right. So we need to find the description that says pi over 2 to the right, okay? So this one, first one says right pi over 2, so that one's still okay. This next one says none, and we know that it is right pi over 2, so that's not okay. We'll get rid of that one. This one says right pi over 2, so we're still okay. And this one says left pi over 2, and that's wrong as well. All right, the next thing is the period. Now remember, the period comes from 2 pi over b. And we already figured out with this graph that our period is 2 pi. So notice how this one says 2 pi and this one says pi. So it can't be that one as well. So this graph goes with symbol equal sign. Graph L, description, equal sign. And those are the two matches for this equation number 11. If you guys need more help with figuring out these graphs, just let me know.